Today we're going to cover a 2016 Jeep Cherokee wiper and washer system. This is a little more complicated than what we've previously covered, but still relatively straightforward with a few caveats. But we're going to just go through and figure out how each component works and what it will take for the component to operate and what happens when it gets turned on. So first, let's just go through the two-page diagram. We're going to do this without the start-stop system. That adds a little bit more complexity that we can get into at a later date. But today, we're just going to go through looking at these two pages to try to understand how the system works and where we would go to test it. So that being said, let's get after it. Let's go through and just ID our components first. So we have two whole pages here to look at. Let's just start at the bottom. So we have our front washer fluid level sensor in the washer fluid reservoir. There's two wires going to it and they're labeled washer fluid level sensor switch, and then low wash switch return 1. And then you can see we have our rear wiper motor that's got two wires and a ground. And the one is motor control and the other is park switch sense. We're going to go up to the next one in line. Here is the headlamp washer motor on the washer fluid reservoir. So that motor runs just the headlamp washer. And you can see that's pretty simple. So it's a motor, it's got one supply from a relay, it says, and a fixed ground, or a permanent ground. And then we go over here to the left side and we have the rain light sensor module. And that has a fused feed, a permanent ground, and a LIN bus line, which means there is no analog data that comes from this module. So it communicates over the data line system using LIN bus 1. Now we're going to go up here to the power distribution center assembly. We have the headlamp washer relay. We have the run 2 relay. So when the run 2 relay is active, and it doesn't give us all of the relay, and it's in a checked box. So we know something controls this relay, but we don't know what it is. And maybe it doesn't matter right now. But as long as when we want our headlamp washer to work, we have power at this fuse, we don't even care what activates this run relay. And you can see this also says hot with run accessory relay 1 energized, which is different than run relay 2. And this comes down and feeds fuse 95. Fuse 41, if you come up here and follow it to this splice and then over here to this splice, it's hot at all times. So we know there's power here, and power at this fuse all the time. When the run accessory relay 1 is energized, we have power on fuse 95. And when run relay 2 is energized, it controls this relay, switches on this side of the relay, and then we will have power on fuse 40, 20 amp fuse. And we can see that this feeds the headlamp washer relay, which makes sense, right? So that feeds directly to the washer motor, sorry, not relay, that's the relay. Fuse 41, which is hot at all times, goes over here, and that's on 1 to the first page. So we'll look at that, and so just remember that the 1 on the right side of the first page is a hot at all time feed from fuse 41. And then fuse 95, a 10 amp fuse, comes down and feeds the rain light sensor module, which communicates over LIN bus. So that's everything on page 2. Now let's go up to the first component on page 1 from the bottom up, is the instrument cluster. That communicates over CAN-C over the computer data line system. Well, I know there's more wires that go to this because of the checked box. I have no idea why the cluster is part of this circuit. Maybe in the theory and operation, it'll tell me. Maybe it's obvious, like there's a wiper on symbol in the cluster. I don't know. And frankly, I don't care. I don't know why they put that in here, but I probably don't need to know that. But maybe I do. Again, it depends on what we're diagnosing and why. But right now, we're just trying to understand how the system works. So the next one up is the steering control module on the steering column. That uses LIN bus CBC3 on the computer data lines. And see there's a circuit ID here that says D403. If we go down to this LIN bus at the rain light sensor module, that's D401. So chances are this is a different LIN bus system than this. Not only because the callout's different here, but because the circuit ID is different. That's important to understand. And again, we'll follow that, see where it goes. And the steering control module also communicates over the CAN-C network on the computer data line system, which means this CAN-C network and this CAN-C network are going to be the same. They're going to be bused together somewhere, more than likely. And we'd have to look at our computer data line diagram to find that out. But only if we have communication issues or we suspect that we're not getting an input. And so we may not even need that. But it's important to understand that the steering control module has something to do with the wiper operation. We don't know what yet because we haven't got that far in the diagram. But the next component up is the front wiper motor. And that's got 4 wires. And we know it only has 4 wires because of the solid box around it, as long as the wiring diagram is correct. So now we can look at these. This is wiper low speed control OP. Operation maybe? I don't know. And we can look that up. So I don't know what that means, but we know we can follow it up to a relay. And wiper high speed control also up to the relay. Alright, so chances are these get fed power through this relay, because we know this is on 87A and 87, so we know that this is going to get some kind of current delivered here. And then we have our wiper park switch sense, and then a permanent ground. So we know if we follow this up, it probably goes to a computer because it's looking for the park switch sense. So that way the body control module knows what position the motor's in. So this wire is going to get pulled high or pulled low, depending on how the circuit works, in order to let the computer know when the wipers are in the park position. So the next component, also 2 wires and a solid box. So we know that more than likely these are the only 2 wires in our windshield washer pump. But they're labeled kind of weird. One says front wash pump motor control, and the other one says rear wash pump motor control. So that's kind of weird, right? And there's no ground. So if you come up here and look, it's fed by 2 different relays. And how would that function? And actually, this diagram must be wrong. It almost has to be wrong. Because how would that washer fluid pump work at this? So you can see that 30 is spliced to fuse 43 that's hot at all times. So here is hot, here is hot. So if this side is switched on, we'd have power at our front motor control, but we don't have a ground. So it would have to run current through this other side up here to 87, which 87 is open. So it wouldn't do anything. We'd just have voltage here and an open relay, and we wouldn't have anything operating. So this pump must work off of magic, or the diagram's wrong. More than likely, the diagram's wrong, right? Because, I mean, unless Chrysler Engineering knows something about electricity that I don't, which it's possible, but so unless this has a permanent ground that's not labeled here, there is no way for current to flow through that motor. So you see, if this was grounded, which is more than likely the case, that these two relays are actually designed upside down. So actually this would be pin 30, and then 87 would be to ground, and then when it's active, you would take the power on 87, connect it to 30, and it would power this side while grounding the other side, if that makes sense. More than likely that's how it works, because of my experience with how these wiper motor or washer motors typically work, is the rear pump, it'll actually pump backwards. So the motor gets ran one direction to pump to the front washers, and then it gets run the opposite direction to pump to the rear washers. More than likely that's how that works. But again, if we don't know, and the diagram doesn't make any sense, we know that we're going to have to look at the theory and operation to understand how this works, to make sure that either we need to find an OE diagram, or we need to deduce how this works. And more than likely, if we go to these relays, if they're accessible in this box and not on a circuit board, we can actually see that these are probably wired with the feed on 87 and the load on 30. And what that would do is 87A would be grounded. So if the load's on 30 connected to 87A, both wires are naturally grounded until one is activated. And if one relay is active, then you have power on one side, ground on the other. That allows current to flow and allows this pump to work. Like I said, more than likely that's how it works. I don't know, and we're not going to take the time to figure it out, but you have all the vehicle information here at your top of the screen, and you can go figure it out. So now we know the body control module is the final component in the diagram. It's got check boxes, so we know there's more involved, not only at the circuit board level, but at the module level as well. The wiper low relay is kind of interesting, because you remember from page 2 that this one here is a hot at all time feed. It comes up here, feeds pin 30, and then this is switched on by the controller here at the wiper high-low relay control. That allows power to feed into the wiper control circuit on the circuit board. And you can see here the high-low relay control and the ground on the control for the high wiper relay. And you can see the fused B plus is here, comes out of the module through pin 30, through pin 87 to the wiper high-speed control. And then when it's active, it feeds the other wire, which is your wiper low-speed control. So now we know how it gets high and low speed to the wiper motor to decide whether it's going to go high or low. And again, knowing that the washer pump relays are more than likely not correct, and maybe I'm just misunderstanding this. Maybe because again, I didn't look at this diagram, until 30 seconds before I started recording this video. This is important to me to do this, so you understand. I'm not studying these diagrams for 20 minutes before I start this video. I'm going to look up the diagram just like I just pulled this vehicle into my bay. We're going to go through it and try to make the most sense we can at the diagram. And I'm going to be wrong. And so don't take all of this as this is absolutely how this works. First of all, this is an aftermarket diagram. And I make mistakes all the time. But the difference is I verify what I think I know versus how it actually works. So if I think I know how something works, I need to take the time to either verify that that's how it works or find contributing evidence that that supports my case for how it works, whether that's in the theory and operation, whether I'm looking up DTCs to walk through a diagnostic, an engineer-written diagnostic process for a specific trouble code to try to deduce how it works based on how they want me to diagnose it. There's a bunch of different ways to figure out how a system works. But what we're covering today is trying to get as much information as we can off the wiring diagrams, and then understanding when we run into a logic issue, like what we have on this rear washer pump assembly. We know that there's only 2 wires going to it, according to the diagram, so it must feed current in one side and out the other. That's really the only way it's going to work, unless it's grounded to the chassis of the washer pump, which isn't very likely. And so in this case, there is no ground provided. So we know that this diagram either has to be wrong, well, the diagram has to be wrong, right? Or these washer pumps were never designed to actually work, which would be really silly. So we know the washer pump works or is designed to work, so this diagram has to be incorrect. Now we could write off this whole diagram and then stop doing the diagnose until we get a hold of a OE diagram, which is nice. This software that I pay for, if I submit a request to this company, they will, in a reasonable amount of time, they will provide me an OE diagram versus this aftermarket written diagram, which these are a lot easier to read, a lot easier to understand, but there's a lot of value in having the actual OE diagram. And I think the next video we're actually going to cover several examples of an OE diagram versus these hand-drawn diagrams. But today's point is to get across that if it doesn't make sense logically, then there's a problem. And in this case, I'm fairly certain that this is not written correctly. But it's easy to miss, too. It's easy to look at this and go, well, that must be how it works, right? So that's what we're looking for. And this actually might get you, if one of these relays isn't working and you turn on the front washer pump relay and you don't have power here, and you should, then you might know that this relay is faulty, especially if you have power at fuse 43. But with the diagram being unreliable, I'd be going after another diagram before I go condemning anything. But again, if I go to this wiper motor or this washer motor and there is no other ground and there's only 2 wires, that's the only way it can work. It can only work if there's a difference in potential between pin 1 and pin 2 or vice versa. So if I have this plugged in and I back probe both of these and one reads 12 volts and one reads 0, then I know that my pump is not working because there's a difference in potential here and the pump doesn't function. I know I have a faulty component regardless of the diagram. Now, if I hook this up and one reads 12 volts and the other one reads 12 volts, then I don't have a difference in potential, and I know I have a problem downstream on my ground circuit, whichever one of these that may be. And we could figure that out by unplugging it, using a test light to see which one lights the test light, and if there's still voltage on the other wire when it's disconnected. So there's a lot of different ways to get to the end result and figure out how it works. But in this case, the diagram isn't the way to figure it out because it doesn't make sense logically, so it's probably wrong. And if we're going to try to use a diagram to figure out how this washer pump works, we need a different diagram. I hope that makes sense. And again, with this wiper low relay over here, getting switched on to provide a wiper control power seems a little confusing as well. I'd be hesitant to say that there's a problem between this circuit and this is how it's designed, or this might actually be accurate, But now that I know I can't trust my washer pump relay circuits, I'm probably not going to rely on the rest of this. So I'm going to go after an OE diagram and then go from there. But let's go look at the start-stop and see if these are the same on there too, because sometimes just looking at the other diagram might be written correctly. So let's go look at page 1 of the start-stop diagram. There's our headlamp washer. I think we're only at, we only have 2 pages on there. So this is the start-stop one. There's our level sensor. Let's look for that motor. There's our washer pump motor with our 2 wires again, and it's a solid box all the way around, so we know those are the only 2 wires. And they go up here, and they go to pin 30. Pin 30. Here, I'll show you these wires again so you can follow them. So they're the brown and yellow and the brown wire, and you can see the brown and yellow comes up through here to pin 30 to this bust ground. That's bust to pin 87, and the front washer pump relay is also pin 30 to this ground on 87A. And you can see this fuse 25 feeds power to both sides of pin 87 on these. So then when it's activated here by the computer, more than likely, right? Pin 4 or 4. So we're going to go up here to 4, go across, and this is actually activated through a power through the washer pump, rear washer pump relay here. So maybe part of the other diagram is actually missing altogether. That would make more sense. That they didn't show this power distribution center assembly showing these washer relays in the second diagram. You can see that this is just the body control module here for the no start stop. So they might have actually eliminated this somehow, but this is how I would expect it to work, which you can see how complicated this gets because pin 86 on both these relays, so this is 4 and this other one is 2. So if we go up here to 4 and 2, they feed into pin 87 of the front and rear washer pump relay at the body control module, just like the other diagram. And then the circuit board or the computer in the body control module is what activates either one of these 2 relays to put power out on this brown and gray wire or this brown and dark blue wire on pin 2 and note 2 and note 4 to the other page. And then here's 2 and here's 4. And if we follow those up, they go through 86 to this common bus. And if we follow this common bus, it goes to ground. You can see that. So that's how these get controlled on, and then these work the way I would expect. So these relays are the circuit from the washer pump motor is grounded on both ends. And then when one side switched to power, it runs in one direction or the other, depending on where you want the washer fluid to pump. I hope that all makes sense. I know this is an extremely complex circuit, but it's unbelievable. A lot of times you'll see really complex circuits on washer pumps and really on wipers. All the way up through the computer age, wipers have actually gotten a little more simple over time compared to how they worked in the 90s and early 2000s. But you can see they're still using quite a few relays to make all this work. Back to the original diagram here. This is page 1. What also I wanted to point out is we have a motor and we have a steering control module, but it doesn't tell us where our actual wiper switch is on the diagram. We can assume that it's in the steering control module here. And it is. And you could verify that relatively quickly, but it's important to understand that they won't always come right out and tell you this is where your wiper switch is. You have to understand that, and then this LIN bus wire here, LIN bus CBC3, is more than likely how the steering control module communicates the switch position to the body control module here. And there is also CAN lines that run down here, so it could be doing it over CAN, but you see this is CAN C, and if we go up here, we also have CAN C. So it may actually tell us over both, but I doubt it. It's more than likely everything's going over CAN bus, or over LIN bus, and then CAN C is for everything else. But that may not be the case since they give us both different networks. So again, that's scanner, right? We're definitely going to need to have a scanner hooked up so we can see the data in the body control module and see the data in the steering control module and make sure that the steering control module sees the switch become active, and then look in the body control module and make sure it's getting the information and it knows that the switch is active in the body control module before it will do anything with any of these relays. So that's important to understand as well. And more than likely, your washer pump switches are going to be part of that module as well, because we didn't see any physical switches. I know this is a lot to digest. I'm going to stop here. You have the vehicle information up here, and you can dive in deep and look up how all this works. And chances are I probably made a mistake somewhere or interpreted something a little bit incorrectly, and that's okay. When we're in the bay trying to get this done, we are going to interpret things incorrectly, unless you're just really, really, really good at understanding how electricity works, understanding how it all works, and can do it all at 100 miles an hour. I can do it pretty quickly. I've been doing it a long time. I still make mistakes. That's why I don't just go buck wild with tooling when I'm going to test this stuff. I very carefully, with a lot of strategy and thought, decide where I want to do my testing, what do I expect to see from my testing before I do it, and if I don't see what I expect, I need to understand why I'm seeing what I'm seeing. And one of the options might be, hey, this diagram's wrong. Based on what I'm seeing, I don't think I can trust this diagram. So I either need to be extra careful and take extra time to understand on the vehicle how this system would or can work, or I need to find a proper diagram, and chances are the only proper diagram we're going to get is an OE diagram, which may require that I submit a information request, or I may have to get a subscription from Chrysler in this case, or Stellantis, to get the information I need to continue this diagnosis. And all this takes time and energy, even for something as simple as a washer pump, right? If we have an in-op washer pump, and this is the diagram I have, and I measure voltage at both of these, so I know I'm missing a ground, and then I go here and go, well, the ground doesn't exist, so everything's fine. This is normal, right? We should have voltage at both of those when either one of those relays is active. Well, that doesn't make any sense. So now I need a diagram in order to continue this, or maybe I can get lucky enough and look at the alternate diagram and decide that they somehow eliminated this section of the power distribution center from the other diagram, and now I can piece this together and make it make sense. Maybe. But this is a problem that we run into in the field, trying to get jobs done, and this is a simple operation. This is a motor. It can only work one of two ways. Current comes in one side and out the other, or the other way around. So something as simple as a motor control, if the diagram is not correct, you have to either have enough experience and knowledge to carefully reverse engineer that circuit on the vehicle so you understand how it works, or you need a proper diagram. And once you realize you're working off a diagram that's not accurate, you need to stop and make a decision instead of wasting a bunch of time banging your head off the wall, calling the wrong part, or poking around potentially destroying something because you're putting a probe where it doesn't belong, or putting power where it shouldn't, or putting ground where it shouldn't. So it's very important, especially in today's modern vehicles where everything is computer controlled, to absolutely understand how it works before you go making a call or deciding what the next step is. So I hope this helps. If you like what you saw and you want to see more, like, subscribe, comment. Let me know what you don't understand on these wiring diagrams, and I'll do my best to cover that. And I probably will make some of these where I actually study them and just take the time, and I'll have some theory and operation articles pulled up. But I want to more demonstrate how this is done in the bay. When I take in a 2016 Jeep Cherokee with a washer pump issue, I'm not going to spend half an hour looking at the diagram before I work on the vehicle. I'm going to spend 10 minutes looking at the diagram, making sure I grasp how it works and understand what it's going to take to make that thing operate, where the best place to test is, and what I expect when I go to do my tests. And if I can't get that information, then I keep looking. But having the knowledge of understanding how this motor works and what it's going to take to make that motor run, I know I could just go right to this motor with a test light and back probe this with a low current test light or a multimeter, check for voltage, back probe this side, check for voltage when it's active. If I have voltage on both of these, I know I'm missing a ground somewhere. If I don't have voltage on either one of these, I know I'm missing a feed somewhere. If I have voltage on one and 0 volts on the other, well, then I know I have either an open at the motor or a faulty component. So that's why I'm not going to waste half an hour doing all of this. I'm going to look at this motor, go, okay, it's 2 wires, clearly, closed box. I'm going to go to the motor, verify there's only 2 wires, check my power and ground, check my 2 wires for power or ground, see what I have, and then make a decision. Maybe, even though I know these relays are here, so that's not likely the cause, but maybe, I'll go down here and I'll read, 12 volts on pin 1, and on pin 2, I'm going to read 6 volts. Well, then the next thing I'm going to do is I'm going to turn on my duty cycle on my meter or hook a scope up and see, is this pulse width modulated? It wouldn't be very likely, but it could be, right? So, and knowing that it goes to relays, it's not going to be pulse width modulated, but it's important to understand, what do I expect when I back probe these 2 wires? Because if I'm going after an in-op washer pump motor, that's what I'm doing. Chances are I'm not going to test at these relays. If they're easily accessible, I may test at these relays, but if part of the diagram is missing and this doesn't make sense, why am I going to test at the relays? I don't know what to expect. Because if I put power on this side and I have power here, okay, well, that's what the diagram shows, but according to this diagram, that pump can never work because there's no path to ground anywhere. So it can't be right. So instead of banging my head off the wall trying to figure out what the heck's going on here, I'm not. I'm going to go down here, because if I have a smoking gun at the pump, like 12 volts in, 0 volts here, and an in-op pump, I know my pump's faulty. So, and again, that's back probed with the pump hooked up. That's not unplugging it, checking for voltage. That's back probed with the pump hooked up. I should have 12 volts feed and near 0 for ground, because there has to be a difference in potential between these 2 wires for this motor to run. And if that's there, with the pump plugged in, I have a faulty motor. I hope that makes sense. Again, thanks for watching. I'm not going to beat this to death anymore. again, if you like what you see, let me know what you want to see in the future, what you don't understand about wiring diagrams and would like to understand, and we'll do our best to cover it.